Here we have a situation where probabilities are based on frequencies rather than on an experiment and based on outcomes, but it's the exact same idea. So you have two events defined here. A is that the student is female. B is that the student chooses math as their favorite subject. So the probability of A here is that the student is female, so there are 1,600 females, as you can see from the table, looking at the totals column. And then if you look at the grand total, you'll see that there's a total of 3,000 people. Now, most typically, whenever we write probabilities, we write them as decimals, and that's what I'm going to start doing. So you take 1,600 over 3,000, or you get 0.533 as your probability. If we calculate the probability of B here, the probability of B is that the student chooses math. So there are 1,887 students who chose math out of the 3,000, which is a probability of 0.629. The probability of A complement. There's a couple ways to calculate this. You can calculate it by using the table, or you can calculate it by using the complement rule, whichever one you prefer. In this case, I'm just going to use the complement rule and say 1 minus the probability of A. So that's 1 minus 0.533, which in this case is 0.467. Suppose we want the probability of A and B. So this is the overlap, students who both are female and choose math. So there are 1,192 students in both of those categories out of the 3,000. So you get a probability here of 0.397. The probability of A or B, once again you have some options here. I'm going to use the addition rule and say this is the probability of A plus the probability of B minus the probability of A and B. You can always use the table, but I would prefer in the case of a contingency table to go ahead and use this rule. I think it's a little more straightforward. Plus the probability of B is 0.629 minus the intersection is 0.397, and that gives us a total probability of 0.765. And then the last one of these, the probability of A given B. In this case, you have two, in my opinion, kind of equal options in terms of their difficulty. You can just use the table in this case, which is probably what I would do here. Given B means you're only dealing with people who choose math. Out of those people who choose math, how many are female? So there are 1,887 who choose math, and out of those 1,192 are female, so you get a probability of 0.632. If you prefer, you can use the conditional probability rule, which says the probability of A and B over the probability of B. So the probability of A and B is 0.397. You might get a slight bit of rounding error if you divide this, but it'll be basically the same thing, divided by 0.629. You should get the same thing if you use the complement rule. It doesn't really matter which way you do it, and as long as you use the correct procedure, I don't really care which procedure you use.